Okay, so let's get into it. Today we're doing a deep dive on a really specific piece of hardware. It's the NTI E-PBD-DO290 dual photobeam detector.
Right. And our mission here is to really understand what makes a security sensor like this actually reliable. It's all about the details.
And reliability is the whole game. This
Sure.
thing is built from the ground up to cut down on those, frustrating false alarms.
Exactly. And the range is pretty impressive. We're talking up to 590 feet indoors.
Wow, that's huge.
Yeah, and 290 feet outdoors, so substantial coverage.
And this is just one model in a whole line, right? They scale up and down.
They do. You can get a 90-foot version or go all the way up to a 390-foot outdoor model. And the one we're looking at, the 290, it's really efficient.
How so?
It only draws about 74 milliamps of current max. That tells you it's designed for low power situations, think remote sites, battery backup, that kind of thing.
So let's talk about how they get that reliability. They use twin beams, which, it sounds like it just doubles the chance of something failing.
It seems that way, but it's actually the opposite. It's about discrimination.
Okay, explain that. How does having two beams help it tell the difference between a real threat and, say, a bird?
Well, the system is programmed to only trigger an alarm if both infrared beams are broken at the same time. So a single disruption, that's your falling leaf, a bit of debris, a small animal, it just ignores it. It needs a genuine larger object to break both beams.
That makes sense. But what about the environment itself? I mean, heavy rain or fog must cause problems for an infrared beam.
It would, but that's where the optics come in. The sources mention these specialized lensed optics. They basically focus and strengthen the beam.
So it can punch through the interference.
Exactly. It gives it excellent immunity to rain, snow, mist, you name it. And the whole thing is built for harsh climates.
Right, the temperature range was pretty wide.
Super wide. We're talking -13 all the way up to 131 degrees Fahrenheit. Plus, it has an anti-frost system built in and a weatherproof case that filters sunlight.
So they've really thought about keeping it stable long term. I saw they even included a tool for installation.
The laser alignment system, yeah.
That seems almost overkill.
It's critical, though. Over hundreds of feet, even a tiny misalignment can cause failure. The laser guarantees it's perfectly aimed from day one.
And they do something with the frequencies too, right? To stop the sensors from interfering with each other.
That's what they call crosstalk. To prevent that, you can pick from 4 different beam frequencies. So if you have multiple units in a row, they won't accidentally trigger each other.
So once it's triggered, what happens? How does it talk to the main system?
Well, it's not a standalone device. It's designed to plug into a bigger ecosystem.
The ENVIROMUX system.
Exactly. That's the central hub that takes the signal from the sensor and decides what to do next.
And you got a couple of ways to wire it in, which seems handy.
Very handy. You can use a simple 2-wire cable to a digital input, which is kind of the old school way. Or you can use standard network cable like CT5 or CT6 and plug it into an RJ45 sensor port. It gives you flexibility depending on the installation site.
So let's step back. We have this device with twin beams, laser alignment, lensed optics, an anti-frost system. I mean, it's a seriously engineered piece of gear.
It really is, all for extreme reliability.
And the price is $238. That feels surprisingly reasonable for that level of specific engineering.
It does, and that brings up a really interesting point when you compare it to other types of sensors from the same company.
What do you mean?
Well, think about what this sensor does. It detects a physical breach. Now, compare its price to, say, an environmental sensor.
Okay, so this is $238.
Right. Now, an NTI carbon monoxide detector, the ECMD, that's a bit more, at $290, still in the same ballpark.
Okay, makes sense.
But then you look at the NTI hydrogen sulfide detector, the EH2S, and the price jumps to $1,210.
Whoa, that's a huge leap.
It's a massive difference, isn't it? So here's the thought for you to consider. What does that price gap tell us? What does it imply about the complexity, the calibration, or maybe even the danger involved in sensing a perimeter versus sensing a highly toxic gas like hydrogen sulfide? That's something to mull over.